This is 3-1, graphing relationships. A continuous function contains a graph that has no breaks in it. It's a continuous curve. Basically, you can draw the curve without ever picking up your pencil. A function that is discrete, though, contains isolated points. You'd have to pick up your pencil. I think of a discrete graph whenever we would say something like, for each candy sold, $1 will be donated to charity. Since we wouldn't be selling 1.5 candies, for instance, it's not a continuous graph. There's some vocabulary associated with these graphs that help us in word problems to know if the graph is going to increase quickly, slowly, if the graph line is going to be flat, and what that means. So let's take a look at what this is with example 1. In example 1, it says the air temperature was constant for several hours at the beginning of the day. Well, looking at the graphs, graph A and B both show a constant, a straight line for those hours. And then rose steadily. Rose steadily is going to be an increase. And again, graph A and graph B both show that for rose steadily. Next it says stayed the same temperature for most of the day. Well, staying the same temperature for most of the day would have a flat line, like in graph B. And the last one says dropping sharply at sundown. Well, dropping sharply would be a quick drop down. So it's definitely graph B would be our answer. Example 2A, Simon is selling candies to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. The word each usually tells me that I'm going to be looking at a discrete graph. I need to see, does the amount of money depend on the candles sold, or does the amount of candles sold depend on the amount of money? Since the amount of money earned depends on the number of candles sold, the amount of money is our dependent variable. So money earned would be on our y-axis, our dependent variable. And on the x-axis would be the number of candles sold. So for 1 candle sold, he makes $2.50. 2 candles sold, that would be $5. 3 candles, $7.50. 4 candles, $10. And this continues up until he sells 10 candles. It's going to make a perfectly straight line. This is actually a linear equation, which we'll get into at a later date. But the important piece is that this is a discrete graph because you would not sell like 1.27 candles. In example B, Angelica's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. As she increases her pace, her heart rate rises at a steady rate. When she begins to run, her heart rate increases more rapidly and then remains high while she runs. As she decreases her pace, her heart rate slows down and returns to her normal rate. So as you can see, there's a lot of vocabulary in this problem. We first need to see which is our independent and which is our dependent variable. Our dependent is going to go on the y-axis, remember, and our independent will go on the x. So does her heart rate depend on her pace, or does her pacing depend on her heart rate? Since her heart rate depends on her pace, the heart rate would be our dependent variable. And let's put the time it takes for her to be, as the time goes on during the time she's on the treadmill. It's going to be our independent variable. So instead of putting numbers, since I wasn't really provided numbers for this, I'm just going to go through that vocabulary. Angelica's heart rate is being monitored while she exercises on a treadmill. While walking, her heart rate remains the same. So at first, her heart rate is remaining the same. As she increases her pace, her heart rate rises at a steady rate. So let's show rising at a steady rate. It's just kind of going up at a smooth pace here. When she begins to run, her heart rate increases more rapidly. So increases more rapidly would be pretty sharp. And then remains high while she runs. Okay, so it's going to remain high for a bit. As she decreases her pace, her heart rate slows down and returns to her normal rate. So it slows down and then returns to that normal rate. Now this graph is actually continuous despite the fact that I picked up my pencil while I was highlighting the vocabulary, but really you don't need to. It remained the same, rose at a steady rate, increased more rapidly, remains high, and then slows down and returns to normal. That is a continuous graph. Okay, let's write a possible situation for the given graph. On the x-axis we have time, and on the y-axis we have water level. And let's analyze this. So over time, let's see what happened to the water level. Well, at first, it increased steadily, in red there, right here. Okay, so that increased steadily. And then, in blue, remains unchanged or constant, one of those. It remains unchanged or constant. Remains unchanged. And then in green, it's a pretty quick drop there, so we can say decreases, maybe decreases steadily or at a rapid rate. It's kind of in between the two. I'm going to go with decreases steadily. And so my possible situation, I could say something like a water can is filled with water. It sits for a while until some flowers are planted. The water is then emptied on top of the planted flowers. And so that makes sense for what's happening in this continuous graph that we see here. And I've color-coded my word problem here so you can see that for increase steadily, I used red, remains unchanged is what I wrote in blue, and decreases steadily is what I wrote in green.